This is the Automation World Get Your Questions Answered podcast, where we connect with industry experts to get the answers you need about industrial automation technologies. This podcast series is sponsored by Allied Electronics and Automation, carrying the most automation and control brand names in North America. The questions posed in this podcast series all come from automation technology users across the process and discrete manufacturing industries. I'm David Greenfield, Director of Content for Automation World, and in this podcast, we'll be digging deeper into the pros and cons of smart instruments as it pertains to industrial cybersecurity concerns. Now, in our previous podcast on this topic, we focused a lot on the features and capabilities that differentiate smart instruments from the traditional instruments we're all familiar with. But when it comes to securing these devices, it was made clear in part one of this podcast that this is an issue that's still very much evolving. So to help you make sense of this evolving landscape of smart instrument cybersecurity, I'm joined for part two of this podcast by Nathan Hedrick and Ryan Williams, product managers at Endress+Hauser, a supplier of measurement instrumentation, services, and software technologies for industrial process engineering. So to start this discussion, let's characterize the state of cybersecurity for smart instruments. Looking across the market, how would you describe the cybersecurity capabilities of smart instrument technology today?
Hey, David, this is Nate here. I'll start. So the first thing I'd say, and you may hear this as somewhat of a theme for me as I'm talking about it throughout, is that the smart instrument does have a piece of responsibility in the overall cybersecurity of the system, but we also have to treat the system holistically. If we look purely at the smart instrument, then we'll be missing a large part of the scope of the overall security of the system. From the instrumentation perspective itself, there are certainly things that we at Endress+Hauser try to do as a manufacturer to help enable cybersecurity and security in general. A few of those things are different levels of access that we build into our devices, whether that be user changeable passcodes, whether that be following typical standards that we see like ISA 99. When we look at also in the development of our devices, the wireless capabilities, their encryption states for password protections and the way that messages are transmitted. We also look at how we can minimize writing to the devices with hardware, such as dip switches that prevent any sort of writing down to the device. And also one thing we always try to look at is making sure that our devices are not pass-throughs. So essentially, if someone does physically gain access to the device and somehow corrupt it, that it would not be able to pass that information on up the system, and it would only be impacting that device and not the DCS or PLC or any of the customer's business systems.
And one of the key elements that Nathan got a chance to help us understand the state of cybersecurity in context to smart instruments also elaborates on the point where smart instruments, what does that mean? And when we think about instruments that have digital technologies to be able to truly drive more data that can drive knowledge and information in new ways, at Endress+Hauser, we have many vintages of different smart sensor transmitter and instrumentation lines that maybe have not been connected in the past, that now users are looking to connect into more of their digital systems. So when he was really referring to the capabilities, if we think about layers of defense, everything from the instrument design itself to the connectivity, to the user password, to data encryption. It truly is an evolving process, and it's best by looking at it at a policy level in general, but then also getting deep into each instrument type and what its capabilities are with the users, and how do you start putting in layers of defense that ensure that you minimize any risks while still taking advantage of the great opportunity that digital smart instruments provide us.
Okay. Thank you, Nate and Ryan. One quick question following up on that. Nate, you were talking about the different levels of access control that are provided in the smart instruments. Can you clarify, is that done at the instrument level through an interface, or is that something done and handled through a higher level of the cybersecurity system in place in the plant?
I'll speak, I guess, from the instrument perspective and what we do there. We have a number of different ways that you can interact with the device. Part of what makes most of our, especially our flow meters, more modern and on the smart instrument side, so to speak, is the built-in web servers of the device to make a more intuitive user interface that can be connected via a physical LAN connection, or it could be a wireless LAN display, which is an optional purchased option from our devices that allow you to connect that with your handheld, whether that be a smartphone, tablet, or laptop, whatever it is you're carrying around, as long as it's wireless LAN enabled as well. From that, then those layers of user access are programmed so the device has an access code for the web server that you as a user can change to be whatever you'd want it to be. Uh, Moving kind of, I say, upstream from that, still within the device, even let's say you did the wireless LAN access option that can be changed, the password and the username, so the SSID that you see and the password there can be changed to same industry standards that you would have on any wireless enabled devices that you'd have in your plant network. And so then a user from there would have ways of creating firewalls and other user access as to whether or not they could even get on the network in the first place to communicate to those devices. Let's say you had a LAN network, you could control who had access to that, let's say based on the IP requirements on the associated hardware, like a laptop that you might be connecting to that network, as to whether or not the user had rights to that access. So for me, there are definitely things that we've built into the devices so that you have user access rights and can designate who's going to have access to the device to make changes or interact with it at all. But I'm sure there are things upstream of that in the architecture that can also be a limiting factor as to who has access to the device.
Well, so given that and knowing that the various features and capabilities that that are out there and available are going to differ widely from supplier to supplier, is there any specific set of features or capabilities that end users should be looking for in specific products as they investigate the use of smart instruments?
Well, I guess I'd first say the one thing I always recommend to customers, and this is a little bit outside of specifically cybersecurity, is to first look at the initial installed base that you have. I think often when we start talking about smart instruments, there may be an assumption made that I don't have any of those already out there, and so then you start to think, well, what kind of investment do I have to do to even begin to take advantage of what smart instruments bring to the table? And so I always recommend first an installed base audit to take a look at what you already have in facility that may already be, so to speak, smart. That's kind of a buzz term, of course, but there's a lot of devices that have been in the market for many years that have a lot of advanced capabilities in terms of monitoring the health of the device, monitoring the health of the process. That can provide a lot of valuable insight, more than the traditional process variable, pressure, temperature, flow, level, whatever that is. There can be a lot more valuable information to be pulled from those devices that you may already have and have the ability to take advantage of with their existing capabilities, or maybe just some small upgrades rather than having to replace an entire instrument. The second piece of that then is thinking about how you're going to get it. So I always think of it as the three A's. How do you acquire, accumulate, and then assess the data? So the acquisition piece, the acquire piece, comes then to, let's say, the physical layer of how am I communicating to those devices to get data in the first place. The thing I always advocate for is digital communication protocol. Do you have Ethernet IP, HART, Modbus, whatever the digital protocol is that may allow you to get additional data? Because if you're on an analog network, a 4 to 20 milliamp network, that's one process variable per set of wires, unless you're pulling HART from it. And so you need the digital piece to start to be able to take advantage of all of the process variables and diagnostics that are available in smart instrumentation today. So that's kind of the acquire piece. The accumulate piece is having a data historian or some sort of memory associated with the ability to accumulate that data over time. And then the last piece is assess it, whether that's setting limits up front on what is kind of a good measuring range for a particular variable or particular value coming across, or having someone monitoring it 24/7. That's a little more challenging. So typically we like to set around those values so that they know what good looks like, and they can be alarmed if it goes outside of those ranges.
And Nathan, those are great perspectives. As a user is looking at, exactly to Nathan's point around what technologies are available to unlock my smart or digital instrument, as well as the needs from the findings of the audit, and how a user or a department would truly get value out of those additional information sets to improve processes or improve operations. When you're looking at to make those investments, and you're looking at what instrumentation or other pieces and parts that are required, it's definitely important to look at the company or the brand itself. And simply what helps users identify that is what organizations and technologies is the manufacturer or the brands participating in. So as we were talking about common networks and having an open integration position, what goes along with that, there's organizations such as ODVA, Open Device Association, as well as we were talking earlier around ISA. Those organizations are essentially helping work with the manufacturers on designing security in context to the protocols and the certification that the devices are built for. So that just gives really confidence to the user or to the project engineer that's selecting and working through a design plan, is to have the reassurance that the quality manufacturer indeed has security, not only, of course, built to the design of the instrument, but they're also an active participant in the industries to improve it. And that's a good indicator to what you should be looking for. So your investment is a good one.
Okay. So now we've talked a good deal about the cybersecurity features and capabilities on the smart instrument side, but what about the requirements on the end user side? And by that I mean, after all, if the instrument has a good amount of cybersecurity capabilities built in, but the network it connects to isn't very well secured, then all the cybersecurity benefits of that instrument are certainly going to be diminished to some degree. So considering that, what would you say are the cybersecurity table stakes, if you will, for end users when it comes to smart instrument use?
If I'm leading off again, I guess I would go back to what I started to say in the beginning, is that you really have to look at it holistically. And if you don't feel that you're already at a place where your business systems and your internal operations networks are secure, that's the first point. Adding a smart instrument, I don't think, makes you any more or less vulnerable to cybersecurity issues, but you want to make sure that you've got those bases covered first, because it is part of the overall scheme. Smart instruments can add a layer if they're done right in terms of their network security requirements. But generally speaking, I think you're putting the cart before the horse if you don't have your ducks in a row there.
Absolutely. And as Nathan's talking about, that planning process is so important. We often have engagements with customers, helping consult and advise them as we do from the initial point of the instrument. So as the instrument is helping with a measurement point that could be critical to a process, could be critical to an efficiency of a unit or the actual makeup and the chemistry of the product. Assessing those things and have different levels of criticality is the same approach that customers and end users need to build up from their procedures when they evaluate how to unlock those digital or those smart instruments. So to very much to the question, understanding, okay, here's the critical processes that I'm going to measure, and I could use more information, more diagnostics. I want to enable some features on. By default, the instruments are going to be more safety defaulted in. But as an end user has their policies is saying, hey, this is in a non-critical area. When it comes into the impact, we have limited users. There's the opportunity to enable, to say, one version of a safety profile or a security profile, where if it's in a refinery or another application that's more critical and it has more impact and more variability within user groups, then it may have a tighter security profile, which means that indeed those network switches, the interface to the distributed control system, some of those other items need to be part of that security policy. So that's really just thinking about it in a pragmatic approach and laying out a plan, assessing it with a diverse team, not just engineering, not just instrumentation, but also understanding risk and operations is also a best practice from an end user side of what to be prepared for. And ultimately, knowing that, it'll help the smart instrument manufacturer or the application engineer putting it in to know what their requirements are for setting up those features and benefits that really get the best bang for the customer's dollar.
Yeah, just to add to that, Ryan, one of the things that typically when I talk about that install base audit and looking at where you want to implement smart instrumentation and the associated network around it, I think that's a great thing to be assessing as well, is where is the highest value going to be delivered. There again, you don't have to take your entire plant and upgrade the entire system at once. It could be that there's a particular high value application that you start with, and that can also then be a great learning environment where you are testing out on a small scale what you'll want to be doing on a larger scale to make sure that that works before you scale it up.
All right. Thanks, Nate and Ryan. We began this discussion by kind of looking at the current state of smart instrument security and what end users are finding on the market today. But in light of all that's going on around Industry 4.0 and the industrial Internet of Things, and the variety of new products and cybersecurity services that are coming out around that, do you see anything significant in terms of smart instruments now? Do you see anything significant changing in the next few years, or do you see the foreseeable future of 3 to 4 years out that will largely be looking at the same sorts of cybersecurity issues we've been discussing here today?
I guess for me, this is Nate. If I'm thinking about that, I think we're still in the process of adoption of partly what's existing now. I mean, there are always going to be developments. Technology continues to evolve at a faster and faster rate. So saying that there won't be any developments would be, I think, pretty naive and short-sighted of me. But what I can say is that we're starting to see a change in most customers' mentality. And when we first had, I can say, on our flow meters, wireless LAN enabled displays for connecting, we had some customers, many customers who were say, no way, that's not going to happen. We can't have that in our facility. You could even see that with things like Bluetooth on devices, where people were very concerned about how the IT groups within their facilities would respond. And what I've seen over the past few years is more exchange there between what's traditionally been in the wheelhouse of IT and then a group that I continue to see evolving called OT, operations technology. And they're communicating better at more and more of our customer facilities to look at how they can take advantage of some of the advanced capabilities of devices, of smart instruments. Whereas before it was kind of that's IT's realm, and that's not going to happen, to an inner dialogue in that community as to how we can work together to realize the value that's that technology can bring us in a way that is also secure.
Those are some great insights, Nate. I appreciate you sharing that. One of the few other additional topics that we see that are really right in front of us today, and we'll see absolutely in the next few years, and that is we see a larger amount of adoption for those smart instruments or those key measuring points in remote physical locations, as well as locations that are not as safe or available, such as instruments on top of tanks or on mezzanines or in unsafe areas. And then, of course, in remote oil fields or remote water applications, we see that the cybersecurity and the remote management of such instruments are increasing, and as well as we get a lot of requests and are delivering solutions, I would say more predominantly in that space. So I think that's a huge area of growth and adoption within cybersecurity and remote assets. There's a few other motivating things that are helping us that we're seeing right now in the next few years, and that is the topic of mobility. As we see more and more plants and users want to embrace a mobile workforce, as we're all doing a little more with less to be more productive and efficient, we find that that's going to be a huge game changer when it comes to embracing network connections as well as technologies such as Nathan was referring to as enabling more Bluetooth and other types of technologies that enables those mobile devices and those workforces to really get not only information but put into context for action. And we find that that is absolutely a reality today. And as we see that mature and continue, we're going to start to see that more of the norm. So those are just a few more insights to where we see things laying out in our current customer engagements at this point.
Okay, so let's kind of, I guess, wrap up this discussion and sum it up, getting back to the initial question that we received from our reader, looking for a list of pros and cons. So, based on everything we discussed here today and knowing the instruments in the market as you do, is it possible to give kind of a rough list of the pros and cons of smart instruments when it comes to cybersecurity?
I'd say on the pro side, there are instruments now that communicate digitally that maybe you wouldn't call smart in terms of being built with security by its very design. I think as Ryan was speaking to earlier, looking at the partners when you're looking for an instrumentation manufacturer, a partner who is involved with the larger industry discussions, like you mentioned ODVA and ISA. So there are those that have digital protocols that maybe aren't looking at some of the access rights. So if they're not looking at uh, how users can or cannot access their devices, if they're not looking at how to ensure there's not pass through from the device up through the network of any malware, those sorts of topics, then I suppose that could be a concern or a con, because you could compare that to a not smart instrument, let's say, which essentially has no digital communication at all and simply does a 4 to 20, no A to D conversion. So from that perspective, doesn't really offer any room for cybersecurity attack. But I'd say as long as you're looking at vendors who are also building their devices to ensure that cybersecurity defense is enabled, it's really, for me, predominantly on the pros side. In fact, most people asking this question maybe don't even realize, again, to my point about the install base audit, about how many smart devices they actually already have, and haven't been considering this topic maybe as forward thinking because they haven't heard the terms of web server, or they haven't been using the digital protocols. I mean, many devices today with 4 to 20 also have HART. Whether or not they're using HART, it's still there and enabled. And so they may even have smart instruments and really hadn't thought through the cybersecurity process. So to me, it's a pro that the question's even being posed, that people are starting to consider it.
Yeah, great perspectives, Nate. This is Ryan. Just on a short list, I would also add, when it comes into the pro of smart instruments for cybersecurity, again, it's going back to understanding what measurement points or what instruments you feel that you really want to unlock and embrace being connected into these smart networks and into these smart systems. So again, it goes back to the design by the manufacturer, the vendor, and then how you're applying it. So the great news is that if you kind of do a little bit of that planning and due diligence up front, a lot of those considerations for risk have already been designed into the product or into the approved integration type. The other pro is that many of the companies, including Endress+Hauser, have strong partnership alliances as part of open network, as well as integration partners within the interface layers. So seeing those partnerships enables further documentation and more reassurances that these policies can be upheld at an end user level just based on the due diligence done by the manufacturers and the integration functions of that. Some of the cons of the list would be there is a lot of variation across vendors into how they describe these items, features, functions, and connectivity, and even what is built into their devices. So sifting through that and learning is a little bit of an uphill battle, which could be perceived as a barrier. It also goes down to the plant itself and the users and what the policy is and how to interpret that within the plant to feeling comfortable of doing something that hasn't traditionally been done in the plant before. Yeah, so those are the short list of pros and cons. At the end of the day, it just goes back to, what's your benefit versus, your pain and your gains. There's a huge amount of potential with digital instruments and with smart instruments that can really change the value or the user efficiency. It just has to be thought through and vetted out, so you have a plan for integration of some of those key instruments for the benefit of the plant and for the user.
All right. Well, thank you, Nate and Ryan, for joining me for this podcast. And thank you all for out there for listening. And please keep watching this space for more installments of Automation World Get Your Questions Answered. And remember to visit our website at www.automationworld.com to stay on top of the latest industrial automation technology insights, trends, and news.